doing good. I am Jessica Thapa, SEDSKU's current event manager. I welcome you all to the third episode of Talk Show. For today's Space Talk, we have Mr. Rakesh Chandra Prajapati, sir, the CEO of Orient Space Nepal, also alumni of Kathmandu University. Sir has been working on satellite projects such as CanSat and where he also helped in building a Pico satellite, Sanosat 1, which is the first satellite built in Nepal. He's also been educating and promoting space science in Nepal through Orient Space. We welcome you, sir.
Thank you very much. So, how do we start?
Before starting, I'd like you to introduce us about yourself, your work, and how did you start with Sanosat 1 or in space and its objectives, like a small description about all of these.
Okay, yeah. Thank you very much for the invitation. I'm very happy. To see all the KU students. It's been quite a long time. Like I was in KU from 2000 to 2004 as a student and 2004 to 2007 as a teaching assistant. So yeah, it's happy to see all the students. Okay, so by the way, I grew up in Banepa, which is quite near from Kathmandu University. So I did my schooling from Banepa, and then I went to Kathmandu University for undergrad. That was already in 2000 to 2004. And after I finished my undergrad in electronics and communication, I was involved as a teaching assistant till like 2007. I was also doing a research project before joining as a TA for the different projects, let's say roughly 1.5 years as a research and maybe 1.5 years as a teaching assistant. So all 3 years in KU. And then at the end of 2007, I came to Switzerland for my master's in electronics and space technology. And during this time, I was also involved in a project, CubeSat project, one of the first satellite built in Switzerland. And that was launched in 2009. So I came here in 2007. I studied electronics and space technology. And during this time, I was also working on SwissCube. And after I graduated in 2010, I got some job in the university, EPFL, which is in Lausanne near Geneva. Now I'm living in Zurich. And yeah, after a few months, let's say about a year, I got a job in Zurich and then I moved to Zurich in 2011. And then during this time, I had some kind of thoughts like we need to do something in Nepal, promote mainly the space education because I was fascinated with the space, and that's why I came to Switzerland to study space technology and also get involved into the CubeSat. And yeah, that was one of the main factors why I came to Switzerland. Otherwise, all the colleagues, my friends, they were going to USA or mostly in USA. That's why, why I took the different path, like coming to Switzerland. Like not many students come to Switzerland for engineering studies. And yeah, it was mainly the space technology and the CubeSat project. So when I look into the website, then I saw the SwissCube project is going on, and then I sent an email to the professor, and then they said, yeah, you can work on it. So I said, okay, let's go to Switzerland. That's how I ended here in Switzerland, mainly the SwissCube project. And then in 2015, I thought, okay, now it's been quite long. I need to do something regarding, promoting space education in Nepal. And then we started Orion Space. And one of the early phases was CanSat. And now yeah, when we started about CANSAT, like not many people were aware of what is CANSAT. So CANSAT is like a model of satellite. It's not really a satellite, but something that you can, relate one-to-one and say, yeah, this is how the satellite functions and what are the main building blocks of satellite. Like this kind of information you can learn from CANSAT. And the word CANSAT is coming from or derived from can, like a Coca-Cola can or any soft drink can, small size, and sat from satellite. So the satellite of the size of a can, and not, I wouldn't call it a real satellite. It's a mock-up, but then you will learn one-to-one, like how the satellite functions and what are the building blocks. And that's also the fundamental to begin with, because you are learning the basics. And also it's accessible and easy because like basic skills like learning Arduino, this kind of programming is enough to start learning. And I also learned the CANSAT in Japan. So it was a week or two training. And then I came back and then I said, okay, I was approaching some of the students like Abhinav and some other guys, and then I said, okay, let's make CANSAT. That's the beginning of our project, And then after a few years, in 2017, so 2015, we started our activities. And in 17, we registered Orion Space officially. So we registered as a private company. And then during this time, we already finished the CANSAT project and we already started giving training. And now we decided what next. And then we decide, okay, now we are going to build a real satellite, not just the mock-up. And we decided to build a Pocket Cube. So Pocket Cube is again a word derived from pocket and cube. So pocket implying that the satellite, the CubeSat, like a cube structure. So the satellite that fits inside your pocket. So the idea was given by Bob Twiggs, who is also the same guy who gave or who introduced the CubeSat. So it's the same guy who introduced CubeSat, and then he said, yeah, CubeSat is still expensive for the universities and students, so we still need to decrease the size, the weight. The idea behind starting CubeSat is that, the smaller the satellite, the lighter it is, the lesser the amount you have to pay for the launch cost. Because if you want to launch something or satellite, you pay based on the amount of the volume or the weight. The heavier it is, the more you need thrust from the rocket, and that's why it's expensive, because it takes lots of fuel. And if the satellite is light, small, then it is cheaper to launch, and that's the idea. So the other factor is also there. The other factor is that if you are involving students, the students typically they have a year or two, maybe a couple of years before they graduate, and they move on to another project. They don't stay longer, and that's the idea that Bob Twiggs, he came up with CubeSat, saying, okay, we need to find a project, a satellite project, which we can finish within 2 years, so that the student can easily, come in, work, and leave, and move into another lab or another project or graduate. Also, it should be cheaper so that the university can afford such project. So by combining these two factors, smaller, cheaper, and short duration project. And that's the idea of CubeSat. And then he said CubeSat is still expensive for some institute, so we go even smaller. So now CubeSat is 10 centimeter cube, and the Pocket Cube is 5 centimeter cube. And after we learned about this Pocket Cube, we said, okay, we will build Pocket Cube, as this project is, funded by a private company, and we don't have huge money. So I thought Pocket Cube, Pocket Cube would be the best choice to take. And we started our project in 2017, and we already finished the project. But then to launch, we need some other, clearance from the regulatory bodies. and it took some time. So it took time to get the launch. It took time to get the regulatories like frequency approval and everything. So it took some time due to all these factors, which we might discuss later on. But then in very recently, this beginning of this year, on 13th of January 2022, we launched our first satellite built in Nepal. And the students, I think there were like 25, 30 students involved in this project. So later on, we might again discuss deeper, like what are the building blocks of satellite. But then now, like, we have power supply, we have onboard computer, we have payload and all these things, structure. So we have different blocks, and we have blocks. And that's why, like, for every roughly 5 blocks, we have 25 students. And the students, mostly they were from Kathmandu University, but they were also students from outside, like outside in the sense out of KU, like from COPA and from other TU, physics background, not only engineering background. So, and I would like to also emphasize that when you say building satellite, you will not focus only on the satellite. You also need to focus on building the ground station, because once the satellite is in the orbit, once it is launched, you need to receive the data from the satellite. And if you have not thought of build this ground station, because everybody like, okay, let's build satellite. Everybody talking like we need to, or we want to build a satellite, but nobody is talking that, okay, we need to build the ground station too. And if you miss this, then you will not get the able to get the data from the satellite. So you have to equally focus on building the ground station. And for that project, or for that part, we have students coming from COPA. So we have to name some of the students, like, Jiten and Rishabh. They were mainly heavily involved. Even after graduation, I hired them into Orion Space, and they were working full-time on this project. And beside that, there were other KU senior graduates now, like Yezu and Kafle, who is at KU. He's still working as a teaching assistant, I guess. And there are many other students, and some of them already went out for master's degree studies, like Saurabh. Now he is doing master's in satellite technology. He's already finishing this semester. Yeah, so I mean, there were like roughly 25, 30 students from in and out of KU. And yeah, I would say this was one of the success for our students, for as a private company like Orion Space, like to give a message that yes, we can do, or we can build a satellite in Nepal. And to just add a note that we can build bigger satellite provided we have a good funding. So it's not that we are not able to build bigger satellite, but the bigger satellite need also lots of money, not only for the building, also for the launching. Because as the satellite grew, we have to pay the launch cost, which will be again, proportionally expensive because of the mass. So yeah, that's the overview and quick and short introduction. Yeah, I hope it's clear. But on the way, we can discuss more detail.
Yeah, thank you so much, sir. हजुरले सानो सानोले अब ग्राउन्ड स्टेसन डेटाको लागि कलेक्ट गर्नलाई हुन्छ भनेर भन्नुभएको थियो. सो वाट वाज द प्राइमेरी अब्जेक्टिभ्स अफ सानोस्याट, अनि वाट आर द डेटाज रिट्रिभ्ड अहिलेसम्म? January भइसकेपछि इट्स लाइक 5 months.
Yeah, so yeah, thanks for the question. Well, the mission, we can divide, the objective or the mission of the satellite like in different aspects. One of the aspects was that we built it as an educational satellite, so to educate the students, in which we have done and which we succeeded. And our students, like Saurabh, who worked on the satellite, is now doing the master's in space technology, and there are other students who are also going into the same path, doing another. There is another student who is also doing the space technology, master's in space technology. And I mean to say that we were successful in that context, that students were able to build, first of all, because it was an educational, and we were happy that the student worked very hard, because we don't have any initial, guidance. We were doing by our own learning. We were collaborating with other partners around the globe. Like we were being guided by our colleagues from Germany, Spain. It was not that we were, alone. There were friends who were helping us also. But then to do it at the first time, without any guidance was very tough. But then our students, they did not lose their hope. They kept on working till the very end. And so this was one of the, educational satellite we were able to achieve our goal. That's the one of the mission. And technically speaking, the payload, the sensor in the satellite is a radiation sensor. So we are measuring the gamma radiation in the orbit. So while the satellite is revolving around the Earth, it takes about 90 minutes to make one revolution. So that's how fast it is moving. So in 90 minutes, it moves one revolution of the Earth. And during this time, it is also measuring the radiations and then transmitting this data, the measurement value, to the ground station. And our satellite is also, as I said, it's educational satellite, yes. And on the other hand, it is also called amateur satellite. So amateur satellite in the radio satellite. So the idea behind amateur radio satellite means all the amateur radio operators, they can receive our signal from the satellite. It's open for everybody to receive the satellite, the data from the satellite. So we can check in and look into the data also. Like there, it is available online. Maybe I can quickly check Sanosat quickly. Maybe I will have to source the link. Maybe I will come back to this link later. So basically, as I said, we were one of the objective is to take the measurement of the radiation level, and the next objective is to provide the communication between the amateur radio user. So you can send the command or message to the satellite, and it will relay this message to the other person around the globe. Let me quickly share my screen, if you allow me, just a sec, so that you can see the data also. So yeah, this is the, I can make, it's roughly 6 months now. So you can see all these measurements. So this is our satellite, all the data measurement, and all these are the people who helped us to receive the data. And this is the call sign, And then we have the measurements here. So you can see the battery voltage is 3.1 volt, and it is not charging. Maybe it was during the night time, maybe. And you can also see the battery level. So you can see roughly the battery is standing around 3.4 volt. I mean, this, if I say this is the average value, so this is roughly around 3.4 volt. And we can see the charging current. So every time there is a sunlight, then we have the charge. And if there is no sunlight, then we don't have a charging current. And you can see the temperature inside the satellite. So there are two plots. One is the green and one is the yellow. So the two plots are measuring the temperature of the battery and temperature of the communication board, which is both inside the satellite. And the idea behind why we choose to put the temperature sensor in the battery is that if the temperature of the battery is below 0 degree, we will not recharge the battery during this criteria. I mean, we just introduce this criteria for to increase the life of the battery. But anyway, here you can see how the temperature vary inside the satellite. It can dip roughly around let's see, how much is it? Or maybe I can read from here. The minimum temperature is -17, also -19, and maximum temperature is +15, 16. So you can see that the temperature inside the satellite between minus, let's say, roughly 20 and +15. So that's a huge swing, and a lot. And this is happening during the eclipse time, because when the satellite is revolving around the Earth, and the moment when the satellite is on the sun side, when it is on the facing to the sun, it will be very hot. And when the satellite is behind the Earth and on the shadow cast by the Earth, because the satellite is behind the Earth in the sense which is opposite to the sun, and it is on the shadow of the Earth, then the temperature is very low. So you can see the temperature inside the satellite is swinging from -20 to +15, and that happens every 90 minutes. So you can imagine how hostile the environment, And this is the measurement from our sensor, the radiation sensor, and there is this baseline, the red line, which is the typical value we should see. But now we are seeing, a little bit scattered number, some points which are above this nominal value. This nominal value, we got it from the paper from NASA. So they said in the low Earth orbit, the typical radiation levels would be this 4 microsievert per hour. And yeah, so we have a few below the line, and this is the nominal line, and some measurements above. And there is another thing that we are measuring, and this is the number of resets. So the satellite gets resets due to radiation also, because it will hit some components, or it will make short circuits or something, and it will introduce reset. So what we can see is that the reset is proportional to the radiation also. And this is very interesting. Yeah, you can see here the reset here is quite low, and here you can see the radiation is also not too much. And if there is a lot of radiation, then you can see faster reset. And the counter is reset after 256, I think. Yeah, every 256 sound, it will go down to 0 and count back again. So yeah, this is our data from our satellite, and you can see all the ham radio operator who are supporting us to receive these data. So anybody can set up a ground station. We are using SatNOX ground station, and if you are a ham radio user, please set up your own ground station, and you have all the components and guidance from the SatNOX, and you can start receiving our data from the satellite. So yeah, this is our information about the satellite, our mission to the measurement of the radiation, to provide the communication for the amateur radio operator, and as an educational satellite, we are also happy that we accomplish to teach the students the space technology and how to build satellite in Nepal. Yeah, thank you.
Thank you, sir. This made us more clear about the SANOSAT objectives. Moving further, yeah, we had a question. How can we be member of Orion Space, Vanita?
Okay. This is, quite tricky, because Orion Space is not like an organization. It's a private company, as I already mentioned in the very beginning. So we are like a company trying to develop satellite in Nepal and to promote. Yeah, we have our social responsibility also. The basic idea, the main objective, or the main seed that we started Orion Space is that to promote space technology in Nepal. So we have this social obligation that, of course, we want to support and guide and help the students. So I would say it's not an organization, so I would say it would be nice if you decide to do thesis or internship. In that scenario, we welcome all the students. At the moment, we have 2 groups from Kathmandu University doing their thesis, and 2 groups from IOE Pulchok doing undergraduate thesis. So you can, I mean, if you are like a, undergraduate student, you can do a thesis work. And if you are a school or college or still as a university students, please come and visit our company. Maybe you can have a look and find something like maybe an internship or maybe some voluntary work. Yeah, that would be the way out. But to be a member, it's not an organization. Sorry for that. Yeah.
Thank you so much, sir, for your answer. Moving forward, so there's this question which says, can Orient Space provide us payload and propulsion building and assembling training?
Yeah, we can do that. We have lots of training. We gave a lot of training in Nepal and outside of Nepal. I have here a training kit also. So this is the satellite training kit. So we use this kit for training how the satellite is built and how it works. So inside there is, now I cannot open anyway. So there are some PCB boards, and with this you can learn the space technology and satellite technology. And we have many more other training kits, which I don't have it with me now. But yeah, we are thinking about the propulsion system also. So maybe we will introduce soon training on propulsion. Now we are focused on ground station, so we can give a training on ground station. So if you are willing to build SATNOX ground station, then we can help you to guide and to give a training. And if you cannot find the materials easily in the market, then we already have all the materials, and we can provide all the materials necessary to build the ground station. So at the moment, we have ground station training and satellite training, which we already have been doing this for quite long now. And in Nepal as well. Last time, like when I say last time in context of Nepal, it's been quite long, maybe a year or maybe a year and a half ago. We were in Pokhara to give the training. But then outside of Nepal, like we gave training in Sri Lanka, Pakistan, and now due to COVID, we changed our all the teaching materials and everything into online. So now you can order the kit. We will post it, and after you've received the kit, we will send you the video link, and we will set up an interactive session like now to give a training online. And on this regard, we have training. We give training in Estonia, Romania, Germany, Spain, USA. So yeah, there are many other countries like where we gave the training, and they really enjoyed it. In Malaysia also, they are building. I mean, when I say they, I mean our colleagues in Malaysia. They are building Pocket Cube, and we were happy to help them and also give a training. And they bought our training kit. So, and also one of the students from Malaysia came to Nepal to do internship. So he learned how we are building the satellite, and he went back to Malaysia and shared what he learned in Nepal. So our colleagues in Malaysia, and now they are building their own Pocket Cube. So yes, we have training at the moment, the satellite and ground station, and we are planning for the propulsion system also. And beside that, if you are willing to build and launch satellite, we also provide this. So please contact us anytime. Yeah.
Thank you, sir. अघि भर्खर एकजनाले टेक्स्टमा लेख्नुभएको थियो, what are the projects, ongoing projects Orient Space is doing अहिले भनेर.
So right now we are building a satellite and for our client, and which is planned to be launched first half of 2023, or let's say next year. So next year there will be, I mean, this is not our satellite, so it's not like we are going to launch, or Nepal or Orion Space is going to launch, but we are building a satellite for our client, and they are launching in 2023, next year. So this is ongoing project, and besides there are other projects as well, and also the other project like based on thesis, because we encourage more thesis, because the outcome is more effective, because the students get time to work for a whole 1 year, and then we will guide them, and we get some concrete output from this thesis. So there are other 2-3 topics which is ongoing, and yeah, we have also projects from other country, like from Germany. We have also a small project coming, and from Spain. So yeah, we have small projects coming, and then yeah, I cannot tell every detailed project, but yes, we have project, and we welcome every student. If you have something different idea and you want to test it, you want to build it, contact us. Maybe we might like your idea and we might work on the project. Not necessary that you have to fit into our project. We have some projects ongoing, but maybe you might not be interested in those projects. But if you have your own idea, like you want to build something which might be suitable for satellite or space technology or ground station, you can contact us, and if the topic is suitable and interesting for us, we will definitely start such project.
Thank you, sir. We also had another question in chat, like, what are the requirements for an application or opening time for internship in Orion Space, and how do we get internship, like procedures in Orion Space?
Yeah, you can just pass by and just stop by, or we don't have restriction. The minimum requirement would be that you might need a paper from your university or college stating that you will be doing, thesis or internship for this starting date and end date, and then we can accommodate you in our place. So it's not that difficult. Last time, one of the student, he just appeared of nowhere and said, "Yeah, I want to do internship," and then we could not say no, and then he's working in Orion Space now. So we don't have such restriction. Please, you are welcome anytime. Maybe you need to bring some document from the university stating that you have this internship period for your credits, then we can handle the rest. Yeah.
Thank you, sir. I guess this made the person clear. We have another question, which is, can new age materials like Kevlar or carbon nanotubes be used in satellite or spacecraft? If so, how?
Uh-huh. Well, nowadays we have this 3D printing and composite material. Yeah, this is whole new topic for us, and we are going to test a 3D printed structure. Let's see how it will function. As I said earlier, we have a client who wanted to test their satellite, and we are building a satellite for them. And there we are using composite material, 3D printed structure. So yeah, we can use these nanotubes or other material, depending, like what kind of applications are you going to use it. So we have 3D printed aluminum alloy as a structure. And in case of the nanotube and carbon nanotube, maybe there might be some application, and it depends, like what you want to do. So we are open with the application, and obviously, we are open with the technology, new technology. So there is no restriction. Obviously, there are some restrictions regarding like what material you can send to space, what kind of because the material also has to sustain the space environment, which you already saw earlier that I mentioned, the temperature can swing from -15 to +10 within 90 minutes, and this is happening every 90 minutes. And yeah, such kind of environment and vacuum, lots of radiation. So space is very hostile environment, and the material that we are going to use should sustain such environment. Otherwise, yeah. So selection of material is also very important during building of satellite. Not only the material, even the glue that we use, and we have to be careful, like what kind of glue we are allowed to use. Even for the soldering, like what kind of soldering paste or soldering wire are we allowed to use, So we have a lot of material selection. We cannot use normal soldering wire for the space grade because of these the formation of whiskers from the solder paste or the solder patch, and maybe that can create short circuit or something like that. So we have to be careful. Also, epoxy kind of these kind of paste, we cannot use any easily available market available epoxy glue or normal glue like super glue that we easily can buy in the store. So such kind of glue is not allowed because they generate lots of outgassing, and we need to control outgassing. So yeah, selection of material is very, very important, but we also welcome new technology, new material, and we can test. Yeah, thank you.
Thank you, sir. Abba, we have two questions related to Higgs field. So, alikati Higgs field ko barema bhaninu, alikati short description.
Okay. Okay. Okay, I mean, this is completely different topic. We are talking about satellite, right? I mean, this belongs to particle physics and very different field. But still, I'm also curious with the particle physics and particle accelerator. I did have some training in CERN in Geneva, so I know a little bit of it, but maybe not the right person to explain. But the Higgs field is like, it's one of the missing part that that proves that the standard model, the particle physics, we have these all the particle, the elementary particle, like what is the fundamental particle, like how tiny we can break till we get the smallest particle. This is the idea of the concept that we are studying in particle physics. So we have the first smallest constituent, let's say, that we can break or that we can observe in a way. Yeah. So it's the atom. And then there is electron and then nucleus, and inside nucleus you have proton and neutron. So then what we can do is we can smash, like if you smash two things, it will break into pieces, and then you can see what is the, like when the two vehicle collide, and you will see the internal parts of the vehicle, right? So that's the, I mean, I'm using layman term now, but still, like the idea behind is that you smash the thing, but then the correct way would be to say the high energy particle physics. So you are speeding the particle at very high speed and smashing them, and then you get some new particle coming out of it, and you will observe the behavior of these, like lifetime, how long they will last and how they will interact with the sensors. And from there you can say, okay, now proton can be divided into Higgs particles, for example. I'm not the right person to explain all this, the boson, everything. So right now I don't remember all these map, because it's been quite long I studied all these things. So all these particles are there, and then one of the missing part was the Higgs particle and the field, Higgs field, and that was discovered in 2012, I guess, or 15, around this time, in CERN, that they noticed the energy, the jump in the energy when they were smashing the particle, and they said, yeah, now we see the particle around what they already predicted, that the range of the energy should be within this value, some electron volt energy. And then, the basic idea is that Higgs fields help to produce the mass in the particle, like how the particle gets the mass is dictated by the Higgs field, let's say like that. So this is coming from that, from there. And then I don't know how much, because I'm not prepared to explain everything like that, and it's been quite long, and I'm not the right person to explain. But still, from what I recall now from my studies and the training that I had at CERN, I can just give you very basic that maybe I will give you the overview, so rather than exact answer at the moment. So in CERN, we have a circular collider, and the idea is that you will accelerate. The first thing is to get the proton. So from where would you get the proton? So from the hydrogen atom, you can extract the proton. And once the proton is extracted, you will put this proton into the electric field, and then you have this electric and magnetic field. So electric field helps to accelerate the particle, and the magnetic field will help to bend the particle. I mean, this is very fundamental. This is already, you studied this in the physics course during the +2 level, where you studied that how the charged particle will behave when it goes into the magnetic field. And there you said it will move into circular path, and you calculated the radius of the circle and everything, which is +2 level physics. And then when the particle, how to accelerate the particle, you have positive and negative field, then it will accelerate along this E field, So E field, the electric field, helps to accelerate the particle, and the magnetic field will help to bend the particle. And that's how you are able to, make a circle of the particle, like it will move in a circle. If there is no magnet, then the particle will go straight. And due to the magnet, it will move in circles. So we have magnetic, or the magnets light in the circular fashion. And also there is another topic I would like to emphasize. It's not only the static field that is, in general, yes, static field helps to accelerate the particle, but then such static field is not enough to pump or to accelerate the charged particle. We need to use RF, radio frequency activated electric field. So there we have cavities, RF cavity, it is called RF cavity, radio frequency. And so in these cavities, it's kind of like a string, like, if you push one time, you will swing one time, and then slowly it will decay. But if you continuously push the swing, and then you will increase the amplitude, like the swing will be continuous, and more the amplitude you can gain. So it's the similar fashion the RF cavity does to the electron. It is like pushing the electron every instant, every moment the field is generated in one direction, and it pushes another field another time. So it's like a pushing every continuous time, not only the static field. So due to this new technology, let's say then, not now, the radio frequency based activated electric field, let's say like that, in a cavity, RF cavity. So that helps to accelerate the particle, and then you want to turn around and you put the magnet and it will turn. And for that magnet also we need very high magnetic power, and there we use superconducting magnets, which is again a different topic, but anyway. So to generate very high magnetic field, we have superconducting magnets, and that helps to turn the particle. And now we have particle which is moving in a circle, and there will be another particle moving in the opposite direction. So we have one particle and another particle moving in a different direction, and they will be smashed at one common point, and then it will generate lots of other particles. And we have camera, let's say in general word camera of the sensor, that will measure these different particles, and then from there we can say, no, yeah, we can see a boson. something like that, some other particle. So that's the idea behind. And for long, physicists were wondering how the particle gain the mass, the weight. These this was missing concept. Like they were not able to explain how these fundamental particles, they have mass, and this is introduced with the Higgs field. So as the particle moves in the Higgs field, it becomes heavier. So that's how they get the mass. But now, yeah, this is the quick and very short whole particle physics in 10 minutes or maybe 5 minutes. But I'm not the right person again. I'm explaining whatever I can recall from my training. I hope I'm able to satisfy.
Yeah, sir. Thank you. यहाँ question पनि थियो हजुरले answer गरेकै answer सँगै related question सँगै related थियो. So I guess it's justified. So moving on, we have like our question say, how can we take the full advantage of AI in this space technology?
Okay, this is another wider, question, like a broad statement or the question how. Well, it depends. Like at the moment, for pico nano satellite, for the satellite that we are building, IoT is the main application, because we don't need a lot of data, a lot of information. So AI is more like lots of information you process and you do something. On the other hand, our satellite is so small that we, at the moment, I don't see how I can justify AI with the pico nano satellite, but we are more focused on IoT. So it is less amount of data, but then collecting from more, and then bringing into the main station, main ground station, or the main server. So satellite is just helping to collect, and then the processing will be done in the ground. So that's the direction that we want to go. But now talking about AI, I don't know how we can use pico nano satellite for AI, but maybe in future. But right now I have no answer, like how we can use AI for the, maybe, yeah, let's say recently we were wondering, like we were thinking about one of the project. We want to detect the orientation of the satellite. So let's say this is the satellite, so quite similar size, very small size, and we have a camera here, and then it will look into the sky, and then it will see the pattern of the satellite, stars. Then maybe AI can help to define to find out where is the satellite oriented, the direction, like where it is looking at, by looking into the pattern of the satellite. Maybe this could be one application. I mean, we were already wondering if we can do this project. We have not started. We have started the project, but not reached into this direction. Now we are working on camera, getting data picture from the camera. So we are still in the early development phase. But then at one point we were wondering if we can use a very simple and small camera with that can fit in such a small satellite and detect where it is looking at just by looking at the stars, because every direction the star pattern, they are different, right? So maybe AI can be one of the application that for us, I mean, I'm being more like, pinpoint, like AI for pico nano satellite for the project that we are developing. So I'm not talking about the whole general application. So for this, I think if you are strong in AI and if you are strong in image processing, and because we want to see the stars and see the pattern and say, yeah, now I'm looking at some direction, and if you see different pattern and you can say, because we already have this star map, just to be clear that wondering how he's saying that, because we have already looked all around the earth in the sky and say, okay, we have a map of the star. So now we can already know if you see certain pattern, then you are at this direction. So we can say in which orientation or in which direction satellite is looking at, just by looking at the stars. So maybe this could be one application for the AI student. If you are interested, the project we already have started. I mean, we are still on the early development phase, still working with the camera, getting the data like that. And we already have the development board using the camera. Right now, I forgot the name of the board. Anyway, it is like an open machine vision board. So right now, I can't remember the name. And we already have this board with the camera itself. And we can use Python programming on this board. So if you are familiar with the AI, familiar with the Python script, familiar with the image processing, please contact me or my engineer at Orion Space. We can definitely work on this project, and maybe in future we can launch the satellite where we have AI to detect the orientation of the satellite. Yeah.
Thank you so well. This is an opportunity, I guess, for people who are good in Python, who are working on AI image processing. So, moving forward, we have like a question in our chat, which is said by Naveen Powderji. He says that what is the latest revolution in satellite communication?
Okay. Because we are working on Pico Nano satellites, so now the questions are more broad. I would say laser communication would be the first thing that would hit in my mind. So yeah, if you are wondering like what kind of communication, what is the highest data rate, I think laser communication would be the technology that for the low Earth orbit, maybe the highest data rate that we can achieve. So maybe if you are interested in communication, check for the laser communication. And also in general, like we have DP Space Network, DSN. So the idea behind the DSN is that, for example, we send lots of spacecraft to Mars or beyond Mars or beyond solar system like Voyager 1, Voyager 2, or any other spacecraft, you know, and we need to constantly have communication with such a spacecraft. And then we in the sense like NASA, like them, and they have the network around the globe, because if we have only one satellite on one side of the, the Earth, then we can communicate only one time, and we will have to wait until this ground station faces to the spacecraft. But now we are having ground station around the Earth, and just for this deep space network. So maybe you can also study about the deep space network, laser communication, and what else. And if you are interested in Pico Nano satellite, what we are doing, maybe you can focus on X band. You know, one of the there are different band, different frequency for the communication. So for our satellite, we are more focused on UHF, ultra high band frequency. So please study about the UHF communication and the X band communication. This is our domain. And if you want to go further, learn more laser communication and DSN network, so deep space network, please study about this. That should be, yeah.
Okay. Thank you so much, sir. Now, I guess this is the last question for today's event. So, how's Nepal's journey has been until now, and how will it lead in the future?
So, like, well, yeah, Nepal in the sense, yeah, I mean, we have very few activities in space technology or building satellite, you know, and it's very recent, and we are one of the pioneers. We are one of the like the early starter, you know. So we started with the CANSAT training, Pocket Cube training, you know. So I would say we are still in the very early development phase. And from Orion Space as a private company, definitely we want to push this boundary. but then due to our limitation, because being a small company, I cannot pour lots and lots of money just to build the satellite. So definitely we need a support from government. If we are willing to build bigger satellite, or if we have to build bigger satellite, we need more funds beyond the reach of a small private company. So from our perspective, I would say we will continue pushing the boundary in the pico nano satellite. We will definitely launch another satellite, maybe not this year, maybe next year. So we already have students doing their thesis work, and their work will be launched in this satellite. So I'm very happy for them also. Yeah, from my side, I don't have much to put. Maybe somebody from the government can emphasize like what is the roadmap. I mean, they already have some roadmap, like they want to put the commercial satellite into geostationary for the communication, but this was delayed. It was like, yeah. So I don't know at the moment from the government side, but definitely they have a roadmap, but it's been delayed. But from our, as a Orion Space, we will continue to push, but then our effort will be only for the pico nano satellite. We cannot, push with the larger satellite unless we get the funding from government or some other source.
Thank you so much, sir.
Yeah.
By now we've come to the end of the event, but before that, I'd like Damodar Dai to take over, and you'll be talking about Pico Hub. Right?
Yeah, thank you.
Okay, thank you, Rakesh sir, for the wonderful session. अनि अहिलेसम्म सुनिदिनु भएकोमा सबैलाई धन्यवाद भन्न चाहन्छु. अनि टकिङ अबाउट पिको ह्याब होइन, पिको ह्याब हामीले चाहिँ सेट्स केओले ह्याब प्रोजेक्ट आइएल ट्रिब्युनल प्रोजेक्ट गर्ने सोचिरहेको थियौँ. अनि राकेश सरले चाहिँ हामीलाई ओरियन स्पेसबाट भनौँ न, ओरियन स्पेसबाट पिको ह्याब एभाइलेबल गरिदिनु भएको थियो. अनि त्यो पिको ह्याबलाई चाहिँ हामीले अब हाम्रो 15 जनाको टिम छ यो आइएल ट्रिब्युनल प्रोजेक्टको सेट्स केयुमा चाहिँ. अनि हामीले काम सुरु गरिसकेका छौँ. अहिले चाहिँ रिसर्च फेजमै छौँ अहिले अब. अनि त्यसपछि फेरि पिको ह्याबलाई चाहिँ सकेसम्म छिटो नै उडाउने खालको कुरा भइरहेको छ हाम्रो टिममा. अनि त्यसपछि चाहिँ हामी डिकोड अहिले चाहिँ डिकोडिङको काम अनि सिग्नल डिकोडिङको काम, जस्तै अघि क्वेसन आएको थियो एउटा कम्युनिकेसनको बारेमा होइन. अनि त्यो पिको ह्याबमा चाहिँ इनबिल्ड त्यो एउटा सर्किट बोर्डमै त्यो सबै कुराहरू छ त्यसमा, सेन्सरहरू अनि प्लस त्यसको एमेचर ह्यामब्यान्ड 2 मिटर ह्यामब्यान्डमा सिग्नल फाल्छ. त्यसले सायद हामीले डिकोड गर्दाखेरि चाहिँ 144.785 मेगाहर्जमा सिग्नल आइरहेको थियो. अनि त्यो सिग्नल चाहिँ एएफएसके डिमोडुलेसन गरेर त्यो सिग्नल एपिआरएस डेटालाई रिसिभ गर्यो. अनि त्यसमा चाहिँ हाम्रो टेम्परेचर अनि त्यसको एल्टिट्युड अनि त्यो जिपिएसको डेटाहरू थियो, त्यो म्यापमा प्लट गरेर पनि हेऱ्यौँ, त्यो एकदम एकुरेट आइरहेको थियो. अनि अहिले चाहिँ त्यो काम होइन. अनि अहिले जस्ट इन हिजो मात्रै एन्टिनाको सिमुलेसनहरू काम सक्यो, त्यो फेब्रिकेसन गर्ने काम बाँकी छ. अनि यसको लागि चाहिँ मैले ओरियन स्पेसलाई फेरि पनि धेरै धेरै धन्यवाद भन्न चाहेँ.
थ्याङ्क यू अल्सो.
हजुर, हामीलाई चाहिँ यो डिभाइसहरू चाहिँ एकदम चाहिरहेको हुन्छ कि अब थ्योरिटिकली पढिरहेको हुन्छ, तर प्र्याक्टिकल्ली कहाँ इम्प्लिमेन्ट गर्ने कुराहरू, मोडुलेसनको कुराहरूदेखि लिएर सिग्नल डिकोडिङको कुराहरू, त्यो चाहिँ यसमा एप्लाई गरेर हामीले सिकिरहेको छौँ. अहिले युजिङ एसडीबाट डिकोड गरिरहेको छौँ. अनि त्यो भएर
ओके द्याट वुड बी भेरी नाइस होइन. वी विल लुक फरवर्ड कस्तो डाटाहरू आउँछ. अनि मेबी यु क्यान मेक अ प्रेजेन्टेसन पनि बिफोर एन्ड आफ्टर होइन. एकदम आई वुड बी भेरी ह्याप्पी, किनकि यो हामीले किनेर ल्याएको धेरै भइसक्यो होइन.
हजुर,
लन्च गर्न चाहिँ पाइरहेको थिएन. सो आइएम भेरी ह्याप्पी, सक्सेसफुल नै होस् भन्न चाहन्छु म पनि. बेस्ट विसेस फर अल द टिम.
थ्याङ्क यू सर. अनि त्यो मौसमले अलिक साथ दिइरहेको छैन, मौसम भन्ने बित्तिकै चाहिँ सुरु गर्छौँ.
अनि वेल लाइक अलिअलि कुराहरू जस्तै अब मसँग यहाँ हाम्रो सेटेलाइटको मोडल पनि छ होइन. मेबी पछि देखाउँछु भनेर राखिरहेको थिएँ मैले. सो अघि अब कम्युनिकेसन सोधेको थियो, के सोधेको थियो. अब आई मिन अब सेटेलाइटमा के कस्तो हुन्छ भन्ने कुरा. अब यो चाहिँ हाम्रो मेजरिङ टेप हो होइन. यु क्यान सी दिस इज द मेजरिङ टेप. हैन मेजिङ टेपको स्याटेलाइटको यो एन्टिना हो
डाइपोल एन्टिना
सो यसलाई यो बाँधेर यसरी राखेको हुन्छ अनि पछि यो स्याटेलाइट लन्च हुन्छ अनि यहाँनिर यसलाई चाहिँ त्यो माछा मार्ने बल्छी हुन्छ नि त्यो धागो त्यसले बाँधेको हुन्छ अनि यो स्पेसमा पुगिसकेपछि त्यो धागो चाहिँ काट्नु त पर्यो अन्त काट्नलाई चाहिँ हामी चाहिँ हिटिङ एलिमेन्ट हुन्छ रेजिस्टर अथवा नाइक्रोम वायर अथवा केही यु क्यान कम अप विथ यर ओन हैन लजिक हिटिङ एलिमेन्ट हुन्छ त्यो हिट भइसकेपछि ब्याट्रीले पावर गर्छ अनि ब्याट्रीले पावर गरेर त्यो हिट भइसकेपछि त्यो धागो चाहिँ चुटिन्छ नाइलनको धागो भनौँ न त्यो चुटेपछि चाहिँ यो एन्टिना चाहिँ यसरी खुल्छ सो दिस इज अ डाइपोल एन्टिना अनि यसले चाहिँ सिग्नलहरू चाहिँ अब ठ्याक्कै यो लन्च भएपछि के भन्छ हुँदैन त्यो पनि एउटा रेगुलेसनहरू पर्ने धेरैवटा रेगुलेसनहरू मध्ये एउटा रेगुलेसन चाहिँ के हो भनेदेखि यु क्यान ओन्ली ट्रान्समिट द सिग्नल आफ्टर रफली हाफ एन आवर होइन सो आधी घन्टापछि मात्र यु विल स्टार्ट सेन्डिङ सिग्नल अथवा डाटा मेसेज अब यसले पठाउने सो यसमा अब के छ भन्दाखेरि यो चाहिँ यो टल्केको चाहिँ अब यो सेन्सर भयो यसले चाहिँ रेडिएसन नाप्छ होइन अघि जुन मैले भने नि रेडिएसन नाप्ने काम गर्छ हाम्रो स्याटेलाइटले यहाँनिर अब यो पावर सप्लाईको लागि सोलर सेलहरू भयो यो सबै ठाउँमा कालो कालो जुन छ नि यो सबै कालो कालोहरू चाहिँ सोलर सेलहरू भयो पावर सप्लाईको लागि अनि अब भित्र चाहिँ अब यहाँनिर देख्न त देखिन्छ आइम नट स्योर इफ यु क्यान सी ओके दिस इज द रेजिस्टर यहाँनिर है अनि यो रेजिस्टर चाहिँ यो धागो अघि छुट्याउनेको लागि भनेर मैले भने नि सो यो रेजिस्टरले चाहिँ यो धागो पनि यहाँ छ हामीसँग यो पनि अलिकति देखिन्छ होला सो यो धागो छ यहाँनिर यो धागो चाहिँ नाइलन त्यो छ नि माछा मार्नको लागि जाने बेलाको युज हुने त्यसकै हो अनि यो चाहिँ त्यो रेजिस्टर तात्तिन्छ अनि त्यसपछि यो चुट्टिन्छ अनि यो चुट्टेपछि यसरी एन्टिना खोल्छ अरु भनेको त यो पावर सप्लाईको लागि यो सोलर प्यानलहरू भयो अब यो सोलर प्यानल पनि अब एकदम महँगो छ हैन स्याटेलाइटको बनाउने बेलामा वान अफ द एक्सपेन्सिभ पार्ट भनेको अहिलेलाई यो हाम्रो केसमा चाहिँ सोलर प्यानल नै हो अरु त्यति महँगो त छैन अब यसमा मेनली अब पावर सप्लाई डिजाइन गर्ने स्टुडेन्टहरू चाहियो यदि स्टुडेन्टले पनि अब पकेट क्युब बनाउने हो भने त्यसपछि कम्युनिकेसनको डिजाइन गर्ने चाहियो हैन अनि माइक्रो कन्ट्रोलर अब हाम्रो यो चाहिँ स्याटेलाइटमा चाहिँ हामीले चाहिँ के भन्छ एटमेगाको चिप युज गरेका थियौं अब आउने नेक्स्ट स्याटेलाइटमा हामी एसटिएम को चिप युज गर्छौं हैन अनि बिकज हुन्छ नि अब बिस्तारै एडभान्स हुँदै जाने त हो नि फर्स्ट टाइममै सबै गर्न सकिन्छ भन्ने छैन बिस्तारै अनि त्यसपछि अब एडिसिएस पार्ट हुन्छ एडिसिएस को काम भनेको चाहिँ अब स्याटेलाइट अब यो स्याटेलाइटमा यो सेन्सर चाहिँ जहाँ फर्के पनि हुन्छ के यसले चाहिँ जता फर्के पनि यसले चाहिँ अब रेडिएसन नाप्छ अनि यो डाटा चाहिँ एन्टिनाले तल ग्राउन्ड स्टेसनलाई पठाउँछ यदि अब यो सेन्सरको ठाउँमा चाहिँ क्यामेरा राख्ने हो र क्यामेराले चाहिँ अब अर्थको फोटो खिच्ने हो भने त क्यामेरा सुड डाइरेक्ट टुवर्ड्स द अर्थ नै अनि त्यो डाइरेक्ट गर्नको लागि मेकानिजम चाहियो किनकि अहिले म घुम्नको लागि यतासम्म छु यसरी घुम्छु यता घुम्छु हैन आई क्यान टर्न बिकज आई हेभ समथिङ टु ओके टु एक्ट फोर्स अनि घुम्नलाई तर यो मान कि यो स्याटेलाइट चाहिँ स्पेसमा फ्लोटिङ यस्तै फ्लोट भएर बसिरहेछ अनि स्याटेलाइट त त्यस्तो यता थिचेर यता घुम्छु भन्ने हुँदैन हैन सो टु रोटेट एउटा मेकानिजम हुन्छ हैन एडिसिएस भन्ने अनि त्यो टेक्नोलोजीले चाहिँ हामीले चाहिँ यो स्याटेलाइटलाई चाहिँ घुमाउनमा मद्दत गर्छ हैन अन्त जस्ट इमेजिन यो स्याटेलाइट चाहिँ यसरी स्पेसमा झुन्डेर अब फ्लोट भएर बसिरहेछ यतिकै बसिरहेछ अब यसलाई यता घुमाउनु पर्यो भने त कसरी घुमाउने भन्ने सोच्नु पर्यो नि अनि त्यो चाहिँ अब एडिसिएस को काम हो अब एडिसिएस पनि हामीले प्रोजेक्टहरु अघि एकजना भाइले सोधिरहेको थियो कस्तो कस्तो प्रोजेक्ट छ अब प्रोजेक्टहरुमा अब एडिसिएस को प्रोजेक्ट छ अघि न एआई र इमेज लिने भनेर मैले भने अनि हामी चाहिँ इनिशियल फेजमा छौं भनेर भने हैन इमेजको काम भइराछ सो इमेज प्रोसेसिङ क्यामेराले फोटो लिने यस्तो प्रोजेक्टहरु पनि छ हामीसँग हैन सो वी आर ओपन फर एनी अदर प्रोजेक्ट हैन इफ यु हेभ सम आइडिया यस्तो पनि गर्न मिल्छ भनेर आयो भने पनि हुन्छ अथवा हामीसँग लिस्टहरु छ यस्तो काम गर्नु बाँकी छ भनेर अथवा यस्तो कामहरु भइराछ भनेर सो यु क्यान गेट इन्भल्भ एनी अफ दिस प्रोजेक्ट्स अरू त त्यही हो अनि अब आइएम अल्सो थ्याङ्कफुल टु आवर इन्जिनियर्सहरू होइन जो चाहिँ अब पहिलादेखि काम गर्नेहरू अनि अहिले नयाँ आएको जस्तै अब ऋषभ भन्ने छ उसले चाहिँ पुल्चोकबाट ग्रेजुएट गर्यो अनि उसको कामहरू राम्रो लागेर हामीले हायर गऱ्यौँ होइन जितेन छ हि इज फ्रम केयु अनि ऊ चाहिँ अब सुरुदेखि नै क्यानस्याटको पालोदेखि नै काम गर्दा गर्दा पकेट क्युब अहिलेसम्म पनि ओराइन स्पेसमै छ होइन अनि अब अरू स्टुडेन्टहरू अथवा इन्जिनियरहरू चाहिँ अब छोडेर पनि कति गइसक्यो अब कोरियामा पढ्न गइरहेछ जर्मनीमा आइरहेछ लाइक स्टडिजको लागि पनि होइन अब या आई थिङ्क जस्ट यु क्यान ड्रप यर सिभी होइन अनि हामीसँग प्रोजेक्ट छ अब म्याचिङ सिना ऊ छ सिभी अथवा इन्ट्रेस्टसँग म्याच छ भने चाहिँ डेफिनेटली वी क्यान डु इट होइन भने चाहिँ थेसिसमा गर्दा पनि हुन्छ कि देयर आर सो मेनी थिङ वी क्यान डु होइन सेटेलाइटको लागि अहिले भने नि अब हाम्रो थेसिसमा अब केयुकै स्टुडेन्टहरूले चाहिँ अब एसएसडिभी भनेर गरिरहेछ विच इज लाइक ट्रान्समिटिङ इमेज होइन सेटेलाइटले लिएको इमेज चाहिँ ग्राउन्डमा पठाउने हो कि अनि त्यो चाहिँ अब केयुको स्टुडेन्टको एउटा प्रोजेक्ट हो त्यो थेसिस गरिरहेछ सो आफ्टर दे फिनिस होइन we will definitely use this technology in our next satellite हैन त्यस्तै अरू प्रोजेक्टहरु पनि छ मैले एउटा मात्र एक्जाम्पल दिएँ हैन सो थेसिस मेरो विचारमा चाहिँ इन्टर्न भन्दा पनि थेसिस चाहिँ आई वुड प्रिफर किनकि इन्टर्न भनेको 3-4 हप्ताको अथवा केही महिनाको हुन्छ हैन त्यहाँ चाहिँ रिजिड अथवा कन्क्रिट आउटपुट चाहिँ त्यति आउँदैन के मतलब सिक्ने हुन्छ ए ल यस्तो भने अनि के गर्नु अगाडि नै छोडेर जानुपर्ने सिनारियो हुन्छ हैन अब 4 विक्सको इन्टर्न भने हुन्छ सिक्ने कि गर्ने कि के गर्ने थेसिस भयो भने चाहिँ इट्स लाइक 1 फुल इयरको इन्भेस्टमेन्ट हो नि त सो यु क्यान लर्न अ लट अनि त्यसबाट आएको आउटपुट अब एकदम राम्रो छ भने त वी क्यान रियली युज इट इन द सेटेलाइट एन्ड लन्च सो यु क्यान बी प्राउड लाइक मैले गरेको काम हो नि मेरो थेसिस हो नि भन्न पाएँ नि सो त्यही भएर चाहिँ इम्फेसाइज चाहिँ म थेसिसलाई नै दिन्छु कि रादर देन इन्टर्न र त्यो भन्दैमा हामी इट्स नट द्याट आइएम डिस्करेजिङ तर थेसिस गर्नुको फाइदा के भयो भनेदेखि you are putting more effort and you are trying to generate something which might be launched in future र इन्टर्न गर्दाखेरि चाहिँ त्यो सिनारियो चाहिँ हार्डली त्यस्तो चाहिँ हुँदैन गाह्रै हुन्छ थेसिस के अरे इन्टर्नमा गरेको काम चाहिँ सेटेलाइटमा लन्च गर्ने भन्ने कुरा हैन अनि त्यही हो अब ऋषभको थेसिसकै कन्टिन्यू गरेर एडिसिएस हामी बनाउँदैछौँ हैन सो त्यही भएर चाहिँ फाइदा चाहिँ थेसिस गर्नु नै फाइदा छ सो प्लिज कन्ट्याक्ट हैन थेसिसको लागि पनि अब हामीसँग थेसिस नेपालको मात्र मैले कुरा गरेँ बाहिरको स्टुडेन्ट पनि छ अहिले हामीसँग थेसिसमा जर्मनको एकजना तर जर्मन हो हि इज फ्रम नेपाल तर स्टडिङ इन जर्मनी अनि उसको युनिभर्सिटीमा चाहिँ हि इज इन्ट्रेस्टेड ऊ चाहिँ उसको ब्याकग्राउन्ड चाहिँ अब म्याथमेटिक्स हो हैन म्याथमेटिक्सको मान्छेले चाहिँ अब स्पेसमा चाहिँ कस्तो एप्लिकेसन गर्न सकिन्छ भनेर सोधिरहेको थियो एन्ड देयर वी वर अल्सो लुकिङ फर समबडी के म्याथमेटिक्स आएको कोही भएको हुन्थ्यो जस्तो भइरहेको थियो ठ्याक्क त्यही टाइम मिलाएर उसले पनि हामीलाई कन्ट्याक्टमा आइसकेपछि इट वाज अ गेट म्याच भनौँ न हामीले चाहिएको र उसले पनि खोजेको ठ्याक्क भयो अहिले रिसेन्टली अर्को एकजना स्टुडेन्ट पनि छ नेपाली नै जर्मनमा कन्ट्रोल सिस्टमको मास्टर्स गरिरहेछ and he want to learn and use his skill control theory चाहिँ satellite ma ani yeah so he will start maybe next month tira अथवा mid of this August ma so दुईजना जर्मनी को तर नेपाली स्टुडेन्ट अनि यो न अगाडि मैले अघि भनिसके मलेसियाबाट स्टुडेन्ट नेपालमै आएर बसेर कति 3 महिना 6 महिना आई डोन्ट रिमेम्बर अलि इट्स बीन 2 इयर्स आई थिंक सो आई डोन्ट एक्ज्याक्टली रिमेम्बर कति महिना बसेर गयो हैन त्यस्तै गरेर अरु स्टुडेन्टहरु पनि आथे अरु विदेशीहरु पनि नेपाली हैन कि विदेशी तर बाहिर मतलब बाहिर बसेको नेपाली हैन कि विदेशी नै पनि आएर थेसिसहरु प्रोजेक्टहरु गरेर गएको छ हैन सो या एनीबडी क्यान एप्लाई अनि म्याच भयो भने तिम्रो इन्ट्रेस्ट र हाम्रो कामहरु म्याच भयो भने वी क्यान स्टार्ट एनी टाइम त्यही हो
Thank you so much, sir. I guess this is an opportunity for every one of us, especially engineers. And I'm here like, if you're interested, then you can also visit Orange Space. And you know, CV or So now we've come to the end of the event. I'd like to thank you, sir, for coming to this event. It
Thank
was
you.
a wonderful event. We really enjoyed the talk show. And also to all the audience, we also had a Facebook Live audience and here at Meet. So thank you all for joining. Thank you.
Okay, thank you for the invitation, and I'm also very happy to express here to invite more students, not only engineering or mathematics student पनि आयो, अब फिजिक्सको स्टुडेन्ट पनि हामीलाई काम लाग्न सक्छ किनकि अब हाम्रो रेडिएसन सेक्सनमा स्पेसको रेडिएसन